What up, friends? Today we're going to go through some video notes on topic 3.6, which is matrix multiplication. And the target question is, how do I multiply matrices? I just wanted to clarify that a little bit further. So we're going to take a matrix and multiply it by another matrix, not by a scalar. And just like a heads up, this tends to be like an abstract process for some people. It definitely was for me when I first interacted with it. So I just want to get that in your head right away that it is a little bit different. And I just have an example prepared from what you've done before in section 3.5. And what I mean by it's a little bit different, and you don't need to find this anywhere, you can just look at my screen. But like if we had something like the two things we knew before in 3.5, multiplying by a scalar and then addition, what was really nice is it like followed a lot of the rules that we already know, right? Like we have to perform we have to perform the multiplication before the addition. So that's why we just distributed this 3 to everything and we get something new. And then we added them second. So that's nice. That's what our order of operations currently is, multiplication before addition. And then even further, what's nice is like when we added things, we just had this natural idea that like things in the same spot should be added together. And then like just highlighting a few more of those, like this element matched with this one. So when we added them together. And again, I think that's pretty nice and pretty straightforward. And matrix multiplication kind of follows some different rules. There's a different kind of algorithm or list of steps. So if you're in the packet today, I actually want you to skip forward a few pages. So this is the first page of the notes, the second, the third. You guys actually have a blank page between your notes and the homework. And if you don't, for some reason, just take out a separate sheet of paper. You don't need to write down the prompt. I have this like random thing made up, and I just made up a t-shirt store about 5 seconds ago when I was preparing these notes here. And I'm just going to sell some t-shirts. I'm going to sell them in 3 sizes, small, medium, and large. And I'm going to have 3 different varieties of shirts. And each shirt's a little bit different, so they'll cost different money. Now, I just have pictures of the 3 so we can kind of see that they're different. And what I want us to think about is we can use this real life example because we have some grounding on what we're doing here, and we can use it to develop intuition or like an understanding of how we multiply matrices together. So there will be a lot of different ways to think about this problem or maybe figure it out, but kind of follow along with me just so we're developing the use of matrices. So the first thing that we want to do is like, it's hard to organize information, especially in numbers and costs and stuff, horizontally using text. So what I have here, and this would be the appropriate time to start taking some notes with me, is I have some shelves. And I want you to see this, already. See how we can think about this just like a matrix, if I put those there. And you don't need to put those black lines. You can just draw this table. But kind of see how we've created a little matrix where we have spots for different elements, right? There'd be something there, and there. And that's exactly what a store does, right? So they have the 3 different shirts. And then normally when I go shopping at places, like they just have different sizes going up and down. So like I'm just going to label this as small. I'm going to label this as medium. I'm going to label this as large. And we have this kind of generic question. They want us to figure out what size is most profitable. And I haven't filled in the inventory yet. I'll do that in a moment. So let's just make up some like amounts of t-shirts that they have. I guess I'm just going to kind of throw some out there. Let's say there's 3 of these, 2 of those, and 4 of those. 4 of these, 3 and 1. There's actually none of those, 4 of these, and 6 of those. And then again, just to organize my information just a little bit differently, I'm going to list my costs for each one. So the small cost $5, or not the small, excuse me, size 1 costs $5, shirt number 2 costs $7, and shirt number 3 cost $10. So again, I'm asking you to organize the information with me, just again, because we're trying to develop some intuition on how to multiply matrices. So if we wanted to figure out like what size is the most profitable, well, we'd have to figure out how much money we're going to make from the smalls, how much we're going to make from the mediums, and how much we're going to make from the larges. So that's not a very difficult task when we really think about it. So like, I'm just going to show my work down here for a quick second. So let's say we figured out the smalls. What we would do there is we have 3 of shirt number 1, and they each cost $5. Then we'd add the smalls for shirt number 2. There's 2 of them. Right? And then they each cost $7. So 2 times 7. And then we have 4 of these smalls, but since they're shirt number 3, they all each cost $10. So we'd add that. And then we're just kind of doing a lot of this math in our head. It's okay just to have a supporting calculator there with you. But for the smalls, 15 plus 14 plus 40 would give us a total of $69 from smalls. And we'd move on, right? Let's do the same thing from the mediums. is we have 4 mediums in shirt number 1, and they each cost $5. So 4 of those shirts each cost $5. Then we have 3 mediums of shirt number 2, but they each cost $7. So 3 that cost $7. And then at the end, we have 1 medium in in shirt number 3, and shirt number 3 costs $10 each. So then we'd add 1 by 10. And then again here, like I said, you can do this in your head too, but $20 plus 21 plus 10, we only get $51 from the mediums. And then we'll finish up with the larges. We have 0 of the first shirt, so 0 times 5, we're not going to make any money from shirt number 1. We have 4 larges of shirt number 2, and they each cost $7. And then we have 6 larges of shirt number 3, and they each cost $10. So we can kind of see already this is going to be the most, but we have 28 plus 60. So there we get $88. So we've successfully answered the question. Which size is the most profitable? Well, it looks like the larges would be if that's the inventory they had. But that's great. You just multiplied your first matrix or your first matrix set, and it's not crazy. What I want us to see, like, let's force the matrix upon this for a second, right? If I put those fancy brackets, that's all a matrix is just an organization, like kind of like a table, without the rows and the columns being marked, so they kind of take away those, those extra lines. But then we organize the cost as a matrix too, if we really think about it, right? And all we need to do to make something a matrix, put it in those fancy brackets. And I'm just going to put that multiplication there. But what I want us to see what we did is we have this general idea, and this is written already on your notes, that what I'm about to say is that we took this general idea of we multiplied this row, right? Remember, rows go left and right. So we took this row. These were all the smalls. So we had 3, 2, and 4. And we multiplied them by this column. Remember, columns go up and down. So 5, 7, and 10. And we just kept doing that over and over. We took this row, right? And then we multiplied it by this column. And then finally, at the end, we took this row and we multiplied it by this column. So we can kind of just see those colors in our work there. So again, that's written for you on the front page. So I'm just going to show you where it is. I'm going to come back to this. But that's the first thing that's noted up here. When we multiply matrices, we multiply the elements row by column. And then we added their products, right? So that's what we did, right? We took each row, multiplied it by the cost column, which was up and down, and then we added up all those products, and then we got our answer. And we can make our answer a matrix too, which it is. When we multiply 2 matrices, we get another matrix. Now, let's keep going a little bit further, though, in our introduction to learning about matrix and their multiplication. So we first just learned that we multiply row by column, row by column. And let's even further kind of like label these so we can see that pattern. This element here was row 1, column 1. And the way that we got it was by taking the first row and multiplying it by this first column. And that brings up an important thing. Maybe we should label their sizes, right? So this matrix here was 3 rows by 3 columns. The cost matrix was 3 rows by 1 column. So I took the first row and multiplied it by the first column, and the answer was in row 1, column 1. If we look at the next thing, this is in row 2, column 1, and we got that by taking the second row and multiplying it by the first column. And then you can see that third pattern in this answer matrix. It was row 3 and column 1, because again, our answer matrix is only a 3 by 1 to begin with. And we can see that we got the third row first column element by multiplying the third row by the first column. Now there's even more here. What's also super nice, and what's going to be true to always check, we actually can't multiply any matrix by any other matrix. There's actually some rules here. What we need to see is that, did you notice that the inner dimensions were the same? And the outer dimensions were actually the dimensions of our answer. Right, remember our answer matrix down here was 3 by 1. So this first kind of introductory problem, I hope, develops a little bit of an intuition on how we multiply matrices. Now we're going to go up to the rest of our notes and be more formal about it and continue to practice this. So if it didn't sink in after 1, that's totally fine. But let's go to the front of our notes here, and you'll see that next thing that I summarized about checking the sizes. to multiply 2 columns. You can read that to yourself. I actually like to write it in a little bit different of a fashion. It's a little bit easier for me. So I'm just going to label, we're going to have two matrices. So this will be matrix 1, and this will be matrix number 2. And then I'm just going to label some random sizes. Like let's say we had 3 by 3, and we're going to multiply it by a 3 by 1. So what we always have to do to start with matrix multiplication is check to see if it's even possible. So we have to check to see that these inner things must be the same. If they are the same, then what we can check, or what we would then know, not even check, is that we would know that the outer dimensions will give us the size of the answer matrix. Or in other words, the size of their product. So when I multiply these matrices together, I'm just going to put a dot just for multiplication purposes. The size of the resulting matrix is going to be 3 rows by 1 column. So when we jump into a few examples, that's the first thing we always have to do. And I just clarified that on my notes because you'll see it in the directions. It says find the following products. We're going to multiply two matrices, and it just says if it's not possible, write not possible. But just as a reminder, how do we know if it's not possible? We should always just check the sizes of each. So that's your first step, is we see this matrix, and remember rows go first and columns go second. So row 1, row 2, column 1, column 2, column 3. So it is a 2 by 3 matrix. And then the second matrix that we're multiplying it by, 3 rows deep, 2 columns wide. So that is a 3 by 2. So first we check to verify that these two are the same, which they are. So that's good. That means this is going to have a product. And then I'm starting to organize my work in a way that I want you also to organize your work. We know our answer is going to be a 2 by 2 matrix. So I'm going to put my final answer, which I'm just telling myself should be a 2 by 2 matrix. I'm going to put that over here, but we're always going to need to show work. And you're never going to want to go just from a product to an answer. You always need to show us work. So then when you're doing the work, it's okay to kind of like start the matrix on one side. And not, if you're just learning this, it's a little bit hard to judge at times how big to make that matrix, but we'll get through it together. So then what we do then is just remind ourselves that we take a row and multiply it by a column. What I like to do, since I have the ability to erase, I'm just going to label the elements. If this is a 2 by 2, we should have row 1 and row 2, and then column 1 and column 2. So when I put an element here, it's in row 1, column 1. When I put an element here, it's in row 1, column 2. This element there would be row 2, column 1. Whatever I'm going to put here, I could just refer to it in row 2, column 2. So what's nice then is what you figure out, what element do I want in my answer? And that's how I figure out what to multiply. So for instance, right here in our answer matrix, which should contain 4 elements, this is in position row 1, column 1. So to get that answer, I'm going to take row 1 of the first matrix and multiply it by column 1 of the second matrix. Now this is how we want you to show your work. So -6 times 4, right? We're thinking about shirt 1, its cost, shirt 2, its cost, and shirt 3. So we're going to just write our products. So then the second element times the second element. Then we're going to take this third element by that third element. And then just to save some time, I already have the answers like prepared. I'm not going to keep taking out my calculator, but also note that you can do a lot of this in your head without a calculator, like -24 plus 6 minus 3. Right. So when we figure out that product, we're going to get that sum, I guess, the sum of the products. We get -21. So that's what I'm going to put in my answer matrix. And then we just continue that process. So if I want to figure out what goes here, well, this is in row 1, column 2. So to find out what goes there, I'm going to take row 1 and multiply it by column 2. So the first element in row 1 is -6. And then the first element in column 2 is -3. We continue that pattern. The second by the second. So we'd add 3 times -1. And then we have -1 times -2. And when we add up all those products, what we're going to get is the answer of 17. So that goes in row 1, column 2. And you'll notice my work matrix is also a 2 by 2, but I'm just making it bigger to account for all the words that I have to write. So moving forward, this thing here, we need to figure out what number this is. This is in row 2, column 1. So what I would then do to figure out my answer is I would take row 2 and multiply it by column 1. So we just go by elements. So 4 times 4, the first in each. Then we'd add the product of the second of each. And then finally the third and the third. So we'd add 2 times 3. And then once we figure out the sum of those products, we're going to get 12. So that's the final answer in our answer matrix. And then the last thing that we would do to figure out row 2, column 2, is we would take row 2, right, which is there, and multiply it by column 2, which is there. So 4 times -3. And then we'd add -5 times -1. And then finally 2 times -2. And when we add up all those products, we're going to get the answer of -11. So that's our first, example of how we're going to multiply matrices. We're going to move on to example number 2 together. So when we start a new example, right, we shouldn't do a problem that we actually can't do. So we always want to start by checking the size. Row 1, row 2, row 3, column 1, 2, and 3. So this is a 3 by 3 matrix. And then I can see in the second matrix, there's 2 rows and 4 columns. So what we can notice right away is that these here in the middle don't match. So if they don't match, we can't multiply these together. Not possible. Now, example number C is the same exact thing, just with more elements. So what we can see here, let's check with this. It's 4 rows by 3 columns. And then the second one is 3 rows by 2 columns. So our first initial test passes, right? These middle 2 match. So then we know our answer matrix is going to be 4 by 2. So with this one, you're welcome to try it on your own. You're going to get plenty of practice on your homework as well. But if you want to practice this one, just pause the video. But I do have the answer prepared in all my work. So I'm just going to kind of get that rolling here. So again, if you chose to practice this one, there's your work and there is the answer. But again, nothing different. We should just see that there's more things to figure out, just completing the process more and more. Now, coming back together on example number 2, just so I'm not wasting time with my technology, we're going to split this into 2 videos. So this will be in video number 2, because we're going to do this on a calculator as well, just so we can have some quick and easy technology tools to help check answers and use that. So I'm going to do that in video number 2, so that'll be posted. We're going to skip example 3 just momentarily. We'll come back to it. Example number 4, I am going to put in video number 2 as well, because it's easier to look at that on a calculator as well. But I do want to go through example number 5. And the reason I want to go through example number 5 is just what I have over here in the margin is a lot of these word problems, like you're going to need to pre-plan. And just to get that in your head, that when you look at a word problem, there's a lot of different ways we can organize information. Should I put it left to right or up and down? So when you start to read these, you will have to look at the options. But there's some guidance that you can do. So we should see here is we're selling tickets to a football game, and we're charging different prices based on the age categories. Then we have some information about attendance for the first game. And we also have information on attendance for the second game. And what the question is asking us to figure out is to find the revenue from the ticket sales for each game. So when we think about starting to use a matrix to solve these word problems again, what I mentioned is you have to pre-plan. So what I mean by that is with the tickets, I don't know if I should list it, the students, the adults, and the senior citizens, or if I should list it as the students, the adults, and the senior citizens, right? So what I recommend doing is just thinking about the options that you could do. So I could make this a 1 by 3 matrix, or I could make it a 3 by 1. I don't know which way to organize the elements. Now, if we think about the information in game number 2, now you'll see that I am categorizing them into larger groups, tickets and games. So there's 2 games, and I have 3 pieces of information for each game. So again, should I list it as a 2 by 3, or should I list it as a 3 by 2? But then you can go to your answer and think about what should our answer include, right? If I'm supposed to find the revenue for the tickets from each game, well, there's 2 games, so I should find the money from game number 1 and game number 2. Or I could write it like this, right? I'm not exactly sure. So my answer matrix could either be a 1 by 2 or a 2 by 1. So when you approach word problems, you'll need to pre-plan. And then what you can do is start to look and eliminate options. There is no way for me to use this 3 by 1 organization because no matter what I do with this 3 by 1, these middle numbers are never going to match. So I can eliminate that one and say, okay, I have to take a 1 by 3 matrix. And then if I'm taking a 1 by 3 matrix, excuse me, that's kind of bad notation. If I'm going to take a 1 by 3 matrix, whatever number is last in the first matrix needs to be first in the second matrix. So that helps me know how I'm supposed to organize my work. The tickets I'm going to organize into a 1 by 3 matrix, and I'm going to use the game information for a 3 by 2 matrix. So we can set up our ticket information. Now the second thing that goes along with word problems is kind of keeping your order. So I'm about to list the ticket prices. I'm just going to go by age. So I'm first going to do students, which I'm abbreviating, then adult, and I'm also going to abbreviate senior citizens. And we'll just list their prices, right? So we know it's $2.50 for students. We know it is $5 for adults and $4 for senior citizens. Now, when I go to my second matrix, which I know has to be a 3 by 2, right? So we have a 1 by 3 by a 3 by 2. I have to think about how I'd organize the information, but what's really nice is that middle thing, meaning there's something that has to align in both of them. What do I know in both of them? I know something about students, adults, and senior citizens in both of them. So I can use this organization to help me match my structure here. So if I went students and then adults and then senior citizens, I'm going to list those in the same order up and down, right? Because we know we're going to do a row by a column. So I'm first just going to label it with some small numbers or letters so we can see, like first I'd list the students, then the adults, and then the senior citizens. I'm going to erase this from my work or make it smaller in a moment, but it just helps us organize, which then means the piece of information that didn't match, the 2, that must be the games. So like game number 1 and game number 2. So then I can list the information in that order. So for game number 1, there was 120 students, 185 adults, and 34 senior citizens. For game number 2, we list the students first, the adults second, and the senior citizens last. Again, because that's the order. And then we know our matrix at the end, our answer is going to be a 1 by 2, right? Because of those outside dimensions. And just to help us organize our thoughts, I have this nice little fancy highlighter. A 1 by 2 means it's 1 deep and 2 wide. So then recall, and we're going through this, and feel free to pause the video and just get the answer on your own. But we can think about what do we need, and we'll find that piece of information, right? So this right here is in the first row and in the first column. So to get that element, I'm going to take the first row and multiply it by the first column. So when you're starting your work matrix, it's okay just to put one of them because it's sometimes hard to judge how big to make it. We understand. But we can show this work again. So we have $2.50 for the students. There was 120 of them. We'd add $5 for each adult, and there was 185 of them. And then we'd add $4 for each senior citizen, and there was 34 of them. So when we add those all up, we would make this much money. And again, I have that prepared, but you would definitely just type this into your calculator to get that sum. Now, the last element we're missing is in row 1, column 2. So in my work matrix, I'm going to try to put that in the same place, row 1, column 2. So again, I would take the first row in the first matrix and multiply it by the second column. So again, we have $2.50 from each student. There was 150 of them. Then we get $5 from each adult. There's 210 of them. And then we also get $4 from each of the 50 senior citizens. So when we add up all those products, we see that we get the answer of $1,625. So then again, we know that we have 2 games. We listed game number 1 first and game number 2 second. And if we needed to label this as game number 1 and game number 2. So for the first game, our total revenue was $1,361. And for our second game, the total revenue was $1,625. The last part of this, I do want to go back to example number 3. And this is just like a kind of like transitioning. So we can use matrices to solve a lot of problems. Right here, we're applying problems. We have a bunch of known information, but we can also use them for unknown information. So this is a 2-step. They want us to solve for x, y, and z in this product. So in other words, it's just a nice practice of multiplying matrices. So we can see that the first matrix is 3 by 2. The second matrix is 2 by 1. So the middle dimensions match, which is why our answer matrix is a 3 by 1. So what we can do is just set up our work here. So if I want to figure out what y is, well, y is in the first row and the first column. So I'm going to take the first row and multiply it by the first column. So -4 times 3, and then I would add 2 times -5. Now that product there, I'm just going to kind of set up some work here, should give me y. So what we've seen there then is when we add these up, right, that's -22. We know that -22 is in the same spot as y. And then moving forward, we just continue that process. So we can look for this -12, right? That is in row 2, column 1. So I would take row 2 and multiply it by column 1. So I'd get 1 times 3, and then I would add whatever x is times -5. And that should give me the answer of -12. So we have this little equation. 3 plus -5x gives us -12. So when we solve this, like I can add 12 to both sides. So I have 15. And then I would move the x's to the other side by adding them. So we can see that 3 is x. And then the last one here, if I wanted to use this piece of information, which is in the third row and the first column, I would simply take I need another color. I would take the third row and multiply it by the first column. So whatever z was, we'd multiply that by 3, and then we would add -1 times -5, and that should give us the answer of 16. So we can convert that to a little equation. 3z plus 5 is equal to 16. So z looks like it was 11/3. So after this, you're just going to quick jump to that other video to talk about a calculator. So make sure you jump to that.